Now that we know everything about the definite integral, we're going to learn really quickly how to evaluate definite integrals using our calculator. When we have calculator active problems, the AP readers assume that we are just going to write down the justification for what definite integral we are evaluating and then just give an answer accurate to 3 decimal places, because we're going to let the calculator do the heavy lifting as far as evaluating that definite integral. So this is going to look a lot like the work that we did for evaluating derivatives using our calculator, but there are some differences. So to find the exact area between the graph of a function and the horizontal axis, for instance, if we were asked to evaluate this definite integral and it was a calculator active question, the first thing we would do is, just like we did on the derivative, we're going to enter that function into y1. So we're going to hit the y equals button. We're going to be very careful to put, and this is an x here, to put x cubed plus 5x squared minus 3x minus 5. And then we're going to hit that second and quit button so we go back to our home screen. So return to your home screen. Then select the math button. It was the same button that we pushed to find in deriv, but this time instead of choosing 8, we're going to choose 9, because that's going to put FNINT with an open parentheses in our home screen. So this says take the definite integral of whatever function that we put here. So this is what your screen should look like. So using the same process for entering your function into the home screen that we did for derivatives, find your vars button, hit your right arrow button once, and then hit enter twice, and that should enter y1 after that open parentheses in your calculator. So make sure that your home screen looks like this, and then you can move forward with us. So the next thing that you're going to do is you're going to enter a comma after your y1, and then you're going to tell the calculator with respect to what variable. Well, you entered y1 in terms of x, so you need to tell your calculator it's integrating with respect to x. You then add another comma, and you put your lower limit of integration, which should be a number. Again, another comma, and then your upper limit of integration, and make sure you put a closed parentheses at the end. So you're telling your function, find the definite integral, evaluate the definite integral of the function that I entered into y1 with respect to x, and integrate it from -1 to 7. Then all you have to do is hit the enter button, and here is the exact area trapped in the plane between that function from x equal -1 to x equals 7. Remember, when you are in a testing situation, on quizzes and on exams and on the BC exam, you can't just put a bald answer. You have to show the AP reader what you were doing. This may represent the amount of water in a bathtub after the faucet was open, a certain amount of time. But you have to show them that this is the accumulated area in the plane between this function and the horizontal axis from -1 to 7. I don't ever want to see this as your justification. Even though your calculator is doing the heavy lifting, you have to use your brain and understand that this is what that amount represents. So never use calculator syntax for your justification. Use the indefinite integral. All right, so let's do several more examples. The biggest part of this is how you're going to enter this into y1. So make sure that you're really meticulous with your parentheses and division marks and all that. This whole thing is in the denominator, so the whole thing needs to have parentheses around it. You're integrating that function once you put it into y1 with respect to x, starting at 5 and stopping at 10, and then you hit the enter button, and there, accurate to 3 decimal places, is the accumulated area in the plane. This one as well, make good use of parentheses. If you just take off and say, and you enter x minus 2 divided by the quantity x to the 1/3, then since you don't have parentheses around your numerator, then the only thing that's getting divided by this term is 2. So make sure that you have a good use of parentheses. When you have an open parentheses, if you forget to put a closed parentheses, your calculator is going to come back and give you an error. It can only do exactly what you tell it to do. So again, pull up, hit the math button, pull up number 9, FNINT, enter, hitting the vars button, enter y1, comma x, comma lower limit, comma upper limit, close parentheses, and hit enter, and you're guaranteed that that is the exact area in the plane. Here are a couple of more examples that you can try. This one is a little bit different because you don't have a secant of x button on your calculator. You only have a cosine of x button. So you're going to enter 1 over the cosine of x quantity squared. So be very careful and very meticulous. Keep up with all your open parentheses, and you have to have as many closed parentheses all the way down the line. So this is 4x plus the secant of x, which is 1 over cosine of x squared. Okay? And again, same process, math, 9, vars button, comma x, comma lower limit, comma upper limit, and hit your enter and make sure that your answers are accurate to 3 decimal places. The last example here has to do with absolute value, and entering absolute value into your calculator when you get into Y1 is really easy to do. You just have to know where to find it. And the absolute value, if you'll hit second and 0 and enter, it will bring up the catalog. And the very first thing in the catalog is the absolute value function. So when you hit enter, the second brings it up, the 0 brings up the catalog, and then enter will actually select absolute value. So make sure you have pulled up your Y equals tab, then hit these buttons, and you should see ABS and open parentheses when you get that done. You enter 4 minus 2x, remember to close the parentheses, and then go through the steps in the process for getting the definite integral evaluated from x equals 0 to x equals 5. And you should, accurate to 3 decimal places, get this for the answer. All right, so just like we did on derivatives, you can find the area in between a function and the horizontal axis in the graph screen as well. As a matter of fact, it's really cool looking because it shades it in, and students love to use the graph screen. But depending on what your function looks like, we are not, because of the algorithm used there in the graph screen as opposed to the home screen, we are not guaranteed on every type of function accuracy to 3 decimal places. So don't, when you're in a testing situation, you can do it for practice if you want to, but when you're in a testing situation, I want that definite integral evaluated in the home screen and not in the graph screen. All right, so this is one video. Come to class next time. We'll have some examples and we'll practice putting functions into Y1 and evaluating the definite integral and letting our calculator do the hard work for us.